Tuco is already pacing around the room, making me nervous. Welcome back to the stream. Tuco, you know this, okay? Ah, there's our fuzzy hero. Well, welcome back to the stream, folks. A little more kernel debugging is on the menu today. Trying to figure out why the PCM-CIA cards on this old motherboard are acting so flaky under Linux. And the last stream was pretty brief, and it was mostly dealing with unrelated problems, but the kernel debugging there mostly just revealed that it seems to be a problem with I/O or memory resource allocation, and it looks like the code that the problem seems to be in is just littered with debug printfs, or print Ks, or rather debug prints. So I think really first step is just to turn those on and see how far that gets us. It's Tuco. All right. So first step is I've got to remind myself how to enable these dynamic prints in the kernel. Oh man, I might be trying to avoid using this KVM switch. There's always some glitches with my mouse when it's reconnecting. There we go. Okay, lots of fun debugging features here. KGDB is what we were just using last time, which is just GDB attached to the kernel. I don't see a directory for debug print. I think the first time I actually saw a reference to this feature was in the configuration menu, so maybe I'll just go back there. So many debug features. I think it had dynamic in the name. Of course, there are also so many dynamic things in the kernel. Ooh, dynamic debug core. That's gotta be it. And dynamic debug. What's the difference between that? Welcome back to the stream, folks. Yeah, I guess this isn't in debug, it's in admin guide and print K basics. Let's try print K basics. It's the standard tool for printing messages. Yes. Okay, what specific debug functions were we looking for? Let's get this back. All right, this is where our GDB investigation last time started. I set a breakpoint in this function, which was the module init for the parallel ATA PCMCIA adapter. This was supposed to be iterating over this PCMCIA check1 config and then allocating some resources, and it seemed to allocate, or it seemed to seemed to fail really early on in trying to allocate what looked like the IO resources, but they might have been memory. Yeah, I think we ended up here, PCMCIA resource. Dev debug. Is that just an old alias for PR debug? Should I just set kernel-wide debug level logging? It's probably going to be too much over a 115K serial port, but maybe that's a good place to start. Hmm. Gosh, yeah, so I could get fancy and do something like debug equals file, what, drivers slash PCMCIA slash star. Let's try something like that. Oh. Didn't actually want to clear my scroll back when I resized the window. Camera's way too dark. I should have recorded audio of the old place. Somebody says they missed the trains going by. Yeah, it was nice. It was also way too expensive. Okay. That looks like all the stuff that the kernel does on its own before init runs. This is an amount of debugging. And it's hard to tell if the network IRQs are working at this point. The network card got an IP. It seems like maybe we have network IRQs, but not disk IRQs in this state. Looks like yeah. So yeah, we're currently booted up into the mode where the network works, but the disk doesn't. This is kind of nice. It's not what it was doing before. Somebody's wondering what this display is. This is part of the machine that we're trying to boot Linux on. This is a this is an old voting machine. It's just taken apart right now because it's easier to work on without the outer enclosure put together, because it's kind of a beast with the whole thing. But it's got a 1024 by 768 touchscreen and a 486 based motherboard, and we're trying to get a modern Linux kernel and all that booted on it. So it's very much not my old build, or not my own build. It's a thing from the early 2000s using parts from the 90s. Okay, what does this log actually say? All right, 0 interrupts from parallel ATA PCMCIA. It's timing out on ATA commands, so all of that matches what we were seeing before. Is this failing differently with all this debugging enabled? I'm looking for the same error we were tracking down last time, and so far I haven't seen it. Does this actually behave differently to just depending on whether or not enable those extra debugs? Let's see if that's reliable. Okay, let's just try to use a consistent test here. So I'm going to do it once with this command line, just root debug serial console so that I can capture the output. And I'm going to expect this to give me that enomem flavored error coming out of the PATA PCMCIA module in it. And then I'm going to do this again, but add the print k debugging and see if that gives me the different behavior where there's no interrupt coming in, but I get further in binding the device and the network works. I'm also realizing, I don't know if it matters, but I guess one slight difference between this setup and the way that I would usually do things is I am initializing PCMCIA a little bit later because I was poking around and then doing the init span init or exec span init. I wouldn't expect that to matter though. Interesting. So that time we're definitely getting interrupts dropped from the network. And we're getting that PATA PCMCIA probe failed, which was happening in the vicinity of the network initialization just a little bit before it. Okay, let's reset this. Oops. I'm gonna do that. There's a request for context, specifically why, because I do tech stuff on video for your amusement. That's really what it boils down to. Like, this isn't really a learning project for me. I've already spent plenty of time debugging Linux. It isn't because I'm hoping to like use this for something practical. It's because I'm hoping to use it to make weird videos. This certainly does slow down PCMCIA and also maybe generate a bunch of serial interrupts while it's happening. Did that fail differently? Okay, see here, I'm just getting the other failure back. Okay. I don't know whether that difference was due to timing or some other random garbage like that, or whether it was just the slight kernel configuration difference. I'll have to look back at exactly what config I used. Maybe we just boot it like this once more. But now that I've got it reproducing the failure I was interested in, I want to look closer at these logs. I don't know what these different ranges are supposed to represent. I'm assuming that these are relocatable, because I don't know why a device would request like exactly IOs 0 through OX10. This range at 1F is the legacy PC, or the legacy parallel IDE, or parallel ATA IDE interface. This one seems fine. What's hanging out there? I wonder if this is something related to, devices racing for resources as we're booting. Like maybe we just actually don't have enough I/O ports. Why are we doing PCMCIA controller interrupts so frequently? Did the PCMCIA controller also fail to get an interrupt here? I don't know how much of this is normal, but it certainly seems like we're failing to map a lot of different I/O spaces. Right, like, does that really want IO space around 170? And can we supply that? We could. And just give it a chunk of IO space that overlaps that region. Oh, it should already be included. Include 100 to 3AF. Did we not run that user space thingo? That sure looked like the driver bound. Maybe there's just some kind of startup race condition where if we attach this too early, it doesn't actually work. Well, that would be annoying, but at least it would be a user space problem. To go. Okay, now we're back to just having bad parallel ATA interrupts. Two go ones out. Oh, hello, welcome to the stream, folks. I'm trying to get the PCMCIA slots on this old motherboard working with Linux. Let's just see if that reboots any more reliably with a little delay there before the user mode part of the PCMCIA initialization. Let's just do a regular boot. There's the delay I just added. And there's a working disk and no network device. All right, that's like the opposite of what we were just getting. Let's make this bigger. Ah, nice big disk. Yeah, that seems fine. But yeah, we weren't getting a network card at all. So that IO range at 4D0 is the disk on the PC card's socket. There's another request for context. Someone's wondering what I'm going to use this computer for after it works. Whatever it's actually able to do that's interesting to watch at this point. But my original hope was that I could use this to program microcontrollers, like these vintage PIC micros, which I can definitely do under Windows 3.1. I just don't know how to actually get the screen rotated into portrait mode in that setup. So I've been trying to get this working under Linux. So where did the network card get stuck at here? Ooh, is hung? It seems hung. That's interesting. Times like this, it would be useful to have the kernel debugger enabled, but I don't. Well, I guess I need to reproduce at least one of these problems, but with more debugging, because this didn't go anywhere. That 2 goes back. Hey, Duke. Yeah, so the machine itself was designed, well, it was sold in the early 2000s, like I think 2001, 2002, that time period. It was still in use in 2008 for the election, and a lot of the parts are more like mid to late 90s vintage. But it's typical with embedded systems, right, that they don't use like the latest brand new parts. I mean, that's changed a little bit now that everyone's using like cell phone supply chains, which are focused on having the latest shiny new parts. But typically, embedded industrial stuff is going to be based on older tech. Yes, it is a voting machine. It was originally made by Sequoia, which has been acquired by Dominion. It is this industrial 486 motherboard. It's a custom design. It's got a little bit of weird custom hardware on it, but it's mostly normal PC stuff. So yeah, it doesn't look like a voting machine on the desk here necessarily, but that's just because I've had a bunch of test equipment attached to it. Okay, I should attach an actual debugger. Oh, Tuco's sitting here right next to my hand now. Hmm. Hmm. Is it in a serial console now? It doesn't seem crashed. It is serial echoing. Oh. We were waiting on the network to fail. I missed the early user space startup. So I saw that -12 mem, but it seemed like that was before user space would have supplied any resource ranges, so that's perfectly normal. Why? Oh, that's a bunch of GDB stuff, because we must have hit a breakpoint. No? Are we just hopelessly desynchronized now? Maybe I should reassemble this machine so it's more obvious what it looks like. There's a website with some more information about it. Actually, I linked to it on the repo for this project. So it looks like a big suitcase with legs. The legs aren't shown in this photo, but there are like metal tubes in the bottom that you assemble underneath. It stands on those, the screen pops up, there's a little tent that folds out around the screen. So you can roughly see how modern the UI is here. Oh, we don't need the audio so loud. Right, this is why they need a 2D accelerator. They've got a 66 megahertz CPU, and they need to draw this big old user interface on a 1024 by 768 screen. I don't know what color depth they usually run in, but it certainly would be fine for all of this to run in 8-bit per pixel, right? Wow, is that like a zoom in mode? Ooh, that's slow. Gosh. What a bad feature. Yeah, anyway, this was not a good machine. I have it for comedy reasons, not because it's actually good. Gosh, I feel like I'm going around in circles here. There are like 2 or 3 slightly different failure modes that I'm hitting. And like switching my setup between different modes is not really helping, because then it definitely changes how it fails. I was feeling the best about the debug prints. Maybe we just look a little closer at the log that I've already got. And so just to narrate these failures, so here's a boot where the disk is failing to bind, but the network binds with dropped interrupts. Here's one where everything takes longer because debugging is turned on. I don't know if the network's failing. Hmm. Big message buffer. Looks like the disk might be working. These messages are annoying. Interrupts assigned. I don't know if we've actually got any at this point. Oh yeah, and we're getting identify failures. So yeah, no, the disk is definitely not working. It doesn't look like the network even bound. We have memory regions bound for both sockets. We have I/O ports for the socket controller and I/O ports for the disk that isn't working. So yeah, the disk has all of its resources assigned, but it's getting no interrupts, and it seems like that might be the only problem. Whereas the network has other problems. Both cards throw up on PC card control ident. Let's try rerunning the resource assignment and maybe reloading the modules and see if that has an effect. I don't know if I can reload the parallel ATA PCMCIA driver. I could eject and reinsert it, but that was crashing before. I've got the kernel debugger set up this time, so if it does crash, I could just debug that, although that might be a completely unrelated crash. Inject 0. Okay, drivers are unloaded. Let's eject 1 to see if that does anything. Okay, both slots should be ejected. Insert slot 0. Ooh, is it hanging here? This might be a hang. Can I break into the debugger? Maybe I don't actually have the debugger set up here. Is crashed. There's a question in chat about whether it might be expecting a different architecture. I'm not quite sure what that's about, but do you mean I'm not running a Linux distro that's designed for this voting machine? Because I think you're right. No, it's interesting that we might have crashed right after set memmap, right? Because that is an area where, you know, board, like chipset specific bugs are going to exist. Like we already found one that we're trying to work around. Camera is warm. I'm just looking at the debug messages at this point and trying to find anything that's out of the ordinary. This is from one of the runs where the disk controller was getting resources assigned but didn't have a working interrupt. It's using this memory range that we specifically set aside in the bootloader for PC cards. And it's using this IO range that was in the config file that seems to work fine. And trying to use IRQ7, and that's the part that isn't working fine. Oh, there's another error hidden in there. Looks like we were trying to bind the network, but binding failed. Why are these IO space allocations failing? Hmm. I'm concerned that maybe the differences in behavior are related to the actual order that things happen in the kernel when I fire off all these socket startups and mod probes right here. So I'm tempted to actually just try inserting sleeps between each step. There's a question in chat. Someone's wondering if there's not enough memory. It's not actually running out of memory. It's just that there's a limited number of error codes people have in Unix-like systems, and so there's a component that's using enomem to indicate a particular kind of resource exhaustion. We do have 32 megabytes of memory, which is actually plenty. Haven't run out of memory yet, except for that 1 or 2 times I did. But it's mostly been fine. Actually, we should be able to do swap space once we have this card reliably connecting. Trying to keep Tuco on the stream, but this camera keeps overheating. I don't even know if sleep 2 in user space makes any difference when the kernel is taking like 20 seconds to run individual ins mods here. It's just trying resource ranges all over the place, and some of these should be getting hits, just the kernel does not have any I/O ports registered at this point. I almost just want a way to compile in a memory map to the PCMCIA subsystem so I don't have to get it from user space. This is supposed to just be just a config file in user space that a utility reads and stuffs into the kernel. It's just the timing is annoying, because I think it might be that some of these things are failing because the information isn't available at the right time. This doesn't look like a problem, but this might be interesting code to read. Right, I think these are... I don't know where these IO port ranges come from. I thought our config file had fewer IO ranges. Maybe only this first one. Hmm. Maybe it would help to look closer at just alloc IO space. Like, this is showing me what the requests are, but I am still having a hard time understanding just from the logs what the available IO spaces are at any given point in time. Yeah, sorry the Tugo cam is going black. The camera overheats sometimes. That's right. I was assuming these were in a module, but the PCMCIA subsystem itself is actually compiled in, which makes debugging slightly more convenient. So this is deeper inside that same call stack we were debugging earlier, PCMCIA init1 in the parallel ATA driver. And now we're actually in the request IO, which we call this a bunch of times to test different IO configurations, but this seems like it pretty much always fails and returns -22. Okay, IO resource bits 110. So that's IO and what else? I don't know what that bit is for. All right, so we've got a type in these bits starting at bit 8. That's set to IO. We have some other kind of general purpose flags above the type bits, and then we have some type specific stuff below the type bits. The type specific stuff is 10. That doesn't seem to be defined for I/O. So where's that coming from? Is that it? Is the PCMCIA driver storing the mapping number in those bits? I think that's what's going on here. That is worrying, but maybe not actually a problem. I'm not sure if these are supposed to be relocatable, right? Because we were here before in GDB, and I kind of glossed over it because a request starting at IO address 0 doesn't make a ton of sense, but these do get larger later, so it's like a fork in the road in debug strategy, right? Do I step forward and try to get an example that's more realistic, or do I look at this example in more depth? I think I try to find a more realistic example first. So I've got this breakpoint at alloc IO space. I just want to step ahead a few breakpoint hits until I find a better resource. Ooh, illegal instruction. What? I'm assuming something in the debugger went wrong here, and this isn't actually a new problem. Page fault. Okay, well, I guess I reset up that experiment first. Tuco does look kind of great right now, huh? Hmm. Having bad debugger luck now. I should really chroma key Tuco in this layout, right? There we go. Ooh, we cannot continue past that breakpoint. That is interesting. Is there something interesting about the context this was called in, maybe? We should be able to debug anywhere in the kernel with KGDB, as far as I know, except for, like, the internals of the GDB stub itself. Hmm. Oh, I can just put this window right behind Tuco. Okay. Same problem even if I do it immediately. I don't know why we're hitting this. Can we ask for a hardware breakpoint? There's not like a don't overheat setting in the menu on this camera. I don't know. Okay, maybe there's nothing special, and I could just use regular GDB hardware breakpoints. How do those work again? H break. Let's see if that behaves differently. I don't know if this will do automatic hardware breakpoints, but it didn't seem like it was using them. It's possible it just doesn't support that on 486, but I thought we had a hardware breakpoint register. It does kind of look like Tuco's looking at the text file, huh? Should I do the chroma key in the overhead camera too? That's a little weird. I don't know if I'll keep that. It thinks we have a hardware breakpoint. Ooh. Interesting. I wonder if there was something confusing GDB because we hit the next break so very quickly. Because presumably those are all just, right, like I think PCMCIA do loop config is just looking at all the different resource ranges defined in the card's configuration and trying all of this for each of them. Ah, that's much better. Okay, 1F0. This resource should be in use, but at least this is more realistic of a range, so it might be interesting to walk through it now that we have a non-zero number. wanted to go inside there. Okay, well, I'll go inside the next one. Okay, similar situation, just a different IO address. Okay, this is resource non-static, find IO. I wonder if this camera runs cooler if I just don't have a card in it. Or will it just not? It does not output without a card. Okay. Oh, it just doesn't like me removing the card while it's running. Maybe it will run a little cooler if I just take out the SD card. Single stepping is not really working properly right now. Not really sure why. We do have a little more room for the text with Tuco green screened. Maybe I should open the back door, just freeze the whole room a little bit. Ah. Yeah, it is cranky about temperature. So now we're in the kernel's generic resource allocation system. This is labeled PCI IO, but it's not PCI. It's just PCI has eaten everything in the kernel these days. This looks normal. We can walk this list and get the IOs that it thinks are assigned. Yeah, they just named the IO port resource PCI IO, even though it isn't actually PCI. Is there any debugging in this file? Yeah, see, these are the same databases that go into the proc IO ports and proc IO mem files that we've been looking at. And there's a question about whether I've ever worked on Linux before. I mean, yeah, I've done like Linux stuff off and on for a while. I mean, it's basically like working on any other big project, right? You just try to make experiments that tell you in slightly greater detail than before where the problem is, and you keep iterating that. Yeah, just for a little context here, I'm trying to get the PCMCIA ports working on this old embedded PC here, which is a motherboard from a voting machine, sort of an industrial 486 PC. And my I/O options are kind of limited on there. I have a compact flash card slot I can boot off of, but the BIOS is very picky about disk geometries. I have two PCMCIA slots, which are more generally useful, but the PC card controller is a little bit weird, and I've been having to debug it and work around chipset-specific problems. So this piece of the kernel, so I'm just using GDB to do source-level debugging on the kernel. I've been focusing on these errors that are occurring when I expect a driver to bind to the PCMCIA socket, or rather a PCMCIA device. Once that device has actually been noticed in a socket, I try to bind a driver to it, and the driver fails to allocate its I/O port resources. And I'm trying to figure out what's going on underneath that. Yeah, right. There's another comment that's basically this is just making guesses and reading debug output, which is basically how it is. Yeah, and now I'm thinking I just need a little more of an info dump from this kernel resource system, which I can get after it's booted by using those files in proc, but now I'm wondering if there's anything I can enable in the debug output. Oh, I was noticing this behavior. If you're not, apparently it's cap sysadmin, but if you're not root normally, all these resources appear to start and end at 0. Because I don't want you to know where the real memory addresses are if you don't need to know. Let's just keep trying to step through this a little bit. Is this camera cooled off slightly? Combat flashcard, yes. Operating system for battle robots. So that was one of our probe failed. That was interesting, because by the time we were getting to that double underbar find resource, the start addresses were always 0. I don't know what's up with that. Did GCC not survive me switching modes there? Maybe GCC is fine, but my terminal wasn't? Oh, GCC. Or GDB. Curses user interface is not happy right now. Yeah, this feels like we're getting closer to something that could be a problem. I think base 768 is where we're actually trying to allocate I/O, but all of these calls underneath it share the same new entry structure, and it seemed to start at 0. Yeah. And it has different flags. Like, this is starting to smell like we're getting closer, at least, right? Like, we're finding something that seems to be losing information, and it also seems to be in code, which is assuming that we're dealing with PCI when we don't even have PCI. Let's look closer at non-static find IO region. Oh. Why are we making the resource with 0? Okay, I guess that isn't a problem. I just don't understand how this is supposed to work. I guess the 0 must be a don't care. Ah, a line reflects the number of bits to be preserved, so a line acts like an address mask. There's some good bird noises out there that the mic filter was eating. Is that too much echo? Check. That's like a little bit of atmosphere, but coming from a mic that is not as sensitive to EMI as this one. Of course, now the birds are being quiet. Okay, do we see that with a line here? A line optimized out. I mean, it looks like, okay, yeah, what is line F? We have a PCMCIA alignment callback. Oh, there's a bit of bird sound. Yeah, I don't know. Let me know what you folks would prefer. The uncanny quietness of the post-RN noise world, or the... And we've already got a couple of votes against my elevator music from earlier. Or the bird noises. Okay, maybe we can keep looking through find resource just to see how it proceeds in this case. Oh, why are we in assembly here? Just forget how to switch this. No transparent areas in Tuco now. Yeah, thankfully this mic that's providing the atmosphere now doesn't seem to pick up the like ridiculous amounts of electromagnetic interference that I'm bathing this room in. How did we get our 768 back there? What is this even doing? We shouldn't have I/O addresses above 16 bits. Did PCMCIA align do that? Maybe I have to look closer at PCMCIA align. Like, it looks like the inputs to that are reasonable and the output is way out of range. Okay, this is an unrelated invocation, but let's take a look at just some random PCMCIA align, why not? This might be the same region, actually. Maybe I can EQ this a little to get more birds and less just like broadband mess. I don't know if anybody cares. How's the background noise with a low pass filter, maybe? That mask is interesting, right? I can see that meaning different things in different circumstances, like limiting the size of our entire I/O region to 16 bits, which would make sense in, you know, legacy PC architecture. But maybe this is also being interpreted as a mask of which bits have to remain equal to their given values, in which case this would indicate 64 kilobyte alignment, which would give us maybe that result that we got, where things were way too high above the 64K boundary. So let's step inside this. Maybe that's fine. Yeah. Okay, so far so good. I don't know what these are. Are these allocations we've made? I don't know why this is the first address we're considering, if that is actually what's going on. Yeah, the birds are barking now. It's interesting. Excuse me. That seems plausible. That's just not cool. TCMCIA align is definitely returning some numbers that I'm not happy with. So here we have start set to 300, which is more reasonable. Are we having a disagreement about resource size T? Don't tell me this is 16 bits. Is this going to be in like Arch specific headers maybe? Oh, why didn't I hit the next hardware breakpoint? I might have to reset this experiment. Did you get the post beeps at all, or did the low pass filter eat those entirely? Oops. The beeps are loud enough. I suspect even with the filter dropping off like 6 dB or so, they're still plenty loud. Such cat. These are not the right resources, right? I think we want to wait till we're searching for an IO region, because memory regions are not my concern right now, and they are not going to have the same address ranges that are meaningful. Okay, doing some request IO. This looks like the parallel ATA device. Let's confirm by loading the symbols. Mm-hmm. Okay. Now we're asking for a different resource. That was fine. Ooh, return value. It's less fine. Right, we just returned 1024, which seems like a bit of an overreaction trying to, like, 16-bit align something that was more like OX20. But actually just the first part that's available. 1024 is fine. I wasn't expecting it, but that is a valid IO port address. 65,000 whatever certainly isn't, though. Gosh, I don't think next is stepping reliably here. More breakpoint flakiness, right? And there seemed to be an extra breakpoint there that GDB was not actually managing. Trying to skip past it, we just hit it again, and then disabling it and stepping seems to have crashed it. Maybe we go for some heavier weight debugging next. I was hoping to find more print K in this resource code. I was kind of curious how bad it would be if I just turn on all the debug. There's a question in chat. Someone's wondering if there are any cool phone apps to learn CLI. You mean like command lines as a general concept? I don't know what kind of phone you have, but if you have an Android phone that installs regular Android apps, then I would recommend Termux. It's basically just a Linux distribution that runs as an Android app. You can use it for a bunch of things, including just learning Linux. That's right. Debug, not KGDB wait. Then there's another recommendation to get a Bluetooth keyboard if you're planning on typing on your phone in a command line a lot. You could do that. I've actually tried both a lot over the years, and I've just gotten fast enough with my thumbs that I would not use an external keyboard on my phone. But you should definitely try both if you can. You might need to find a different keyboard app, though, that has, like, arrow keys and control keys and stuff, though. Oh, are you looking for more like a directed experience than an open-ended experience? Yeah, no, I don't know anything about like gamified computer learning. I don't actually necessarily think that that whole thing is a good idea. Like I don't know, like, right, if, like, what is the point, right? If you're just trying to learn computing for the sake of learning computing, then, like, actually, what's the point? Like, what am I doing here? I'm making video for all of you. What are you doing out there? I mean, it depends on what your goal is. Like, a lot of people just want to get a job, and I mean, yeah, like, having money and being able to pay your bills is great, but I wouldn't recommend people get, like, psychologically invested in the whole process of computer programming just for that. It doesn't really end well. You know, you'll make okay money for some years, and then you'll get burned out, and either that or you'll end up with a job making something terrible. If you want, like, a way to learn stuff when you're bored, then I mean, you could look for, like, a canned experience of some sort, but really, like, when you're doing that, you're basically asking someone else to have produced, like, an adventure game for you, basically, and then you play the adventure game, which is something you can do. But if you just want to learn, I find it much more straightforward to, like, pick a project. Like, just find something that you're interested in. It doesn't matter if it's important or hard or easy or whatever. All it matters is that you're interested, because the like, motivation and the time that you spend is pretty much all that matters. But I mean, like, if you find that you can do stuff with the command line that you would normally want to do, then that can be a pretty good motivation, right? Like Termux, like, I use that on my phone to do system administration and to manage photos, and, like, you could just try to do stuff like that on your phone, and you, as a side effect, learn how to do some, you know, scripting or whatever. That sure is a lot of extra logging. All right, so we could have logging for, like, all the kernel objects and all the memory allocations. Change all the timing for everything. The secret of computer professionals: we all hate computers. Yeah, basically either computer people hate computers, or they're drinking someone's Kool-Aid at this point. I'm not really sure there are other options. I mean, that's a bad analogy to use, but the whole process of dedicating your life to technology is kind of hard to understand without the context around it that capitalism provides, really. So much debugging. Yeah, I don't know. I don't understand yet why these are all failing. Oh wait, yes. We're still early enough that we don't actually have any resources, right? Okay, maybe this isn't bad. It's just still very verbose. Let's see if we can add some resources. Okay, that was PCMCIA socket startup 0. And 1. There's a comment that somebody has a friend who's interviewing for Palantir and it's making them sad. I mean, it sounds like you've got one less friend. All right, so here's an example of something that is binding to I/O ports correctly, at least. We got 400 to 40F. That was that range at 1024 that we were seeing earlier when we were deeper in the allocation code. Yeah, so we must have tried requesting a bunch of these specific ranges. They all failed. I think we have a range at around OX100, but I guess I don't know why this is failing. But this one succeeds. What does our actual I/O map look like? Oops. Right, it would help if I used my terminal and not my tail to actually send commands. One of these has scroll back and one of these has interactivity. Line buffering would be useful for this. Yeah, so there's something that's bothering me. I don't know why the range we're choosing is at OX400. That's not any of the ranges we supplied here in the config file. Looks like we got I/O ports assigned for the other socket too. Are we just getting different failure modes with everything running this slow due to all the debugging? Is this actually just working? Like, I see, like, I saw the network driver output below, and it looks like we've got dev SDB here. They've both got I/O ports. I haven't seen any IRQ dropped messages, but I don't know that I would in this mess. One and a half million microseconds. Okay, I know this is a mess, but I was just hex dumping the beginning of the storage card, and that seemed to be working. We have a MAC address. Got one Ethernet interrupt dropped message, but it was normal to see one or two of those when the driver loads. There's another one. Okay, we might actually be losing Ethernet interrupts. Yeah, we've got slow pings here. They're taking like 30 or 40 milliseconds. Which, I mean, it's hard to tell based on timing with all this serial debugging. But we're getting more interrupt dropped messages, so I think we're now in the state where the storage card is completely working and the network card is kind of working but dropping interrupts completely. So that's interesting. I don't know how to explain the intermittent problems with the resource assignment except via like order that things happen during boot at this point. I'm getting a bunch of belated debugging help over in YouTube chat. Yeah, no, the sleeps didn't seem to reliably work when I added those in to try to get the order to stay consistent. And like, so here we booted super slowly and we ended up in this one state. I don't know if we would end up in the same state if I rebooted it again. So, gosh. Well, maybe I should wrap this stream up and try to come up with a better plan for the next stream. I mean, one approach to this is to try to just like systematically get a bit more information about what's going on here. So keep the logging, maybe not this cranked up. This is literally just like all the logging I can enable is enabled, which is way too much. Clearly the like interrupt debugging is annoying here, and I had been turning on just the PCMCIA driver logging earlier, but I think I need some of the kernel object stuff too. And I wasn't sure exactly which of those. There's a few people asking questions about like getting involved in Linux kernel stuff or like low-level computer stuff, and there's absolutely nothing magical about Linux. Like, it's just a computer program that a bunch of people maintain until it mostly works. Like, it's got a bunch of kind of weird responsibilities and weird context around it, but it's not that different from any other computer program. You can, I mean, the thing that I'm doing right now is just trying to isolate a problem by running experiments. So I've got this thing that sometimes works and often fails, and I'm trying to, collect data and run experiments and just incrementally chip away at the parts of it that I don't understand until I can actually make some changes that improve it. And that's what I've been doing this whole time. I mean, I went from not knowing anything about this machine to having Linux that kind of works on it, and we're just gradually improving it. I mean, operating systems in general are pretty interesting. Linux is not necessarily a great example of an operating system. Like, all operating systems are terrible. Like, it's just the nature of it. Like, once a piece of software gets large enough that people are using it in so many different ways, it's going to be bad. So like, I've been kind of making peace with that lately, though. Like, I feel like this notion of kind of software purity that a lot of programmers find compelling, and certainly I found found to be like an ideal that I wanted to aim at when I was a younger programmer. I don't think any of that's actually good. I don't think that kind of having a single mental framework that everything fits into is actually a useful approach. It's much more interesting to kind of you know, think about the ways that individual grains of a system grow, and then the boundaries between those grains hold a lot of potential for, you know, how the entire system operates. Maybe before I wrap this up, I should just see if I can get any information out of the 3C589 driver about its interrupt routing. I've also still got that kernel patch that reserves one of the IRQs, and I don't think that's necessary or super helpful. I just haven't removed the patch yet. Gosh, I don't trust anybody who still uses the word cruft unironically. You know who you are. People who think that software being bloated is a real thing. Yeah, none of that's real. It's just like a particular kind of software idealism that people like that doesn't actually serve any goals that are worth serving. Like, there are a lot of ways to build software that turn out to be extremely inhumane if you just focus on making the software into this, like, beautiful, flawless crystal. Yeah, that's a good point, that hardware has a way of being full of enough quirks that refuse to fit into any clean design you started out with. It's not just hardware, though. It's like basically any contact with the outside world, right? Like any clean, pure design doesn't stay that way once you've actually started using it. So software is always this balance between, you know, having a design that works well enough that you can actually make progress while also not getting too mired in the idealism of it all. We played around earlier with setting the interrupt that's used by the i82365 for card insertion detect. I don't know that that super matters. I've seen this thing work all right in situations both where the actual card services IRQ is set and where it's not set. And I think the main trade-off is that we do a poll every second to check for card insertions and removals if there's no IRQ. And I mean, really, on a system with such limited IRQs, polling might not be that bad, but if we do need to change it, it's basically just a pretty inoffensive kernel kernel module option for that. There's a comment that a good ideal would be to make code easy to understand and contribute to. I mean, is that your main priority though? Because like that's always balanced against a bunch of other stuff. Obviously, you know, code that is easier to read is nicer than code that is hard to read. But there's always a bunch of things to balance. And this is why if you look at any real project, it's often a mess because there are just a lot of different priorities that people are always trying to balance. And a lot of things that aren't even, you know, maybe what I would consider a mess tends to like offend a lot of people when we talk about like low-level programming. And I think there's this expectation that things should be simple in a lot of contexts where that's just not really practical. Like the classic conversation that I have with computer science people is like some complaint about a thing that, oh, I don't see why it works this way and this was annoying for me, so I'm going to complain about it. But then like really there's some underlying reason that it is that way usually. But that's just a classic computer science conversation. Everybody has that in the field, right? It's like usually wrong, but it's a thing we do. So the first mention of IRQ4 there. And there we go, set socket. I don't know what's really going on here. The flavor I'm getting from this problem is it seems like maybe something at the chipset level is getting initialized differently depending on whether this IRQ is being used via the PCMCIA bus or via like some other sharing situation. I don't need kernel debugging shell commands in the chat, thanks. That's the other thing with technology is anytime you start to do anything with computers, people start flooding you with information that you don't actually find useful. Like the process of finding the information you actually need is always one of the hardest things in doing anything with technology. And it's not that the information isn't out there. The information's always there. It's just that there's too much of it and you have to figure out what thing to pay attention to next. And so, yeah, like it's not like a linear, straightforward thing for anybody really. It's just a thing you have to kind of like feel your way through. And I think people just have varying levels of experience at that. Anyway, it looks like the IRQ allocation's happening there. I don't know who actually decides on IRQ4 or sets it up at a chipset level. I thought we weren't doing this probe situation for IRQs. I forget why. I thought this was disabled, but we're totally getting output from it. I wonder if the probe is broken. Like, I mean, okay, so I know the probe is broken. Why is this working at all? We looked at this probe, and it's using a register that this chip doesn't even implement. So, like, what is going on here? Are we accidentally getting a hit on IRQ5 because of the serial debugging? I bet that's at least part of the problem, right? Is that this probe works by just generating an IRQ on the PC card controller and then testing to see if an IRQ showed up. So it's not surprising that it's broken here for various reasons. And I think there are actually two reasons why this is broken. I think one reason is that we're getting spurious IRQs due to the serial debugging. And I think another reason is that it's, at least if this is the probe I'm thinking of and it's not like a different probe, then it's using a software interrupt request bit that the chipset we actually have doesn't implement. Most important computer-related skills, managing information overload. Yeah, that's one way to think about it. I mean, there are different kinds of computering, right? Like, there's certainly many things you can do with a computer where you just like learn how to do that one thing, and then you've got a procedure that you can stick with, and that's like how a lot of things work when you're you know, when you're like going down a path that is relatively clear, like, oh, I want to build up skills using this particular program, or, you know, I want to learn a new framework or learn some audio tool or something like that. But then there's just this much more amorphous skill of just like figuring out why it isn't working. And it's not linear, because the whole point is that you're already off track. Like, you already don't know what's going on, and you need to figure out how to get back to a place where you do know something. And so it's less like following a line on a map and more like you're in a dark room sort of feeling your way around looking for a light switch. I mean, I don't know, that's pretty much how I see it, right? Is you don't necessarily have a source of illumination, but you can slowly kind of find something that gives you a little bit of light, and then, you know, make incremental progress from there. There's a request for context. They're wondering if PCMCIA is generally not working, or if it's just a specific card acting up. I think it is somewhere in between. I don't have any evidence that there are any card-specific problems here, so it seems like the problem is like either a bug in the PCMCIA controller itself, or most likely just a bad interaction between the PC card controller I'm using and the Linux driver. I already found one issue and worked around it, where there was a memory region that was being opened for PCMCIA that happened to sit in between the video BIOS and the system BIOS. And because of the way the memory mapping on this motherboard is configured, that actually created a memory mapping priority problem, such that that was supposed to be an unoccupied like hole in memory that you can reuse, but when the PC card driver tried to map it to a PC card, it would actually end up just getting another copy of the BIOS. So I had to work around that by choosing a different address that doesn't overlap with either of the BIOS mappings at all. And now I'm getting a couple of different problems. I've got, I mean, the sort of highest order problem here, the thing that's been around for the longest and that is kind of the most of a showstopper here, is that even not best of case, but most cases I can't actually get both of these cards to get an interrupt assigned. So it's common that I'll turn this thing on, both cards will be recognized, and say one of them has an IRQ and the other one doesn't. Like, and I can understand that maybe being like, if this probe often gives me a result where it gets a hit on IRQ 5 and no others, then maybe it just assigns that to everybody. But I think the results we're seeing here are going to be a little different just depending on timing during the boot, since this seems like we're hitting something kind of racy where, you know, different portions of the kernel or the kernel plus the hardware end up collaborating to create slightly different order of operations every time it boots. There's a question, what chipset is this? It's an AMD 486 compatible system on chip called the SC400. And the system on chip has the 486 core and the PC card controller. It has a few peripherals that we're not using, like a graphics chip and a parallel port, floppy disk controller. Then there's an external Super I/O chip, which has a bunch of peripherals we are using, like a parallel port and a floppy controller and a hard disk controller. The main boot hard disk is compact flash being used in IDE mode, and the BIOS has really antiquated ideas about disk geometry, so that's been kind of frustrating. And there's a question about whether it's the AMD SC400. Yes, that's the chipset I said. It's the ELAN thing is like not the company. There is a company named like ELAN Semiconductors or something like that. That's not this. This is just made by AMD. That's just part of the marketing for this series of chips. Is there an easy way to just disable that probe? I think that might be one thing to do before debugging further, because that probe is probably causing at least part of the non-determinism here. I've always got to warn people though that like learning to do things with computers is like not necessarily a great idea. Like it's kind of fun in some ways, but it's also kind of terrible in more ways. So like, you know, you do you, but I wouldn't actually necessarily recommend it. I kind of wish somebody had told me that when I was younger. I had less of my life invested in this junk. Oh, how bad would it be if I just patched this to return 0? Actually, it might be enough to just do scan to 0, right? Because I think this just doesn't know that scanning is not working unless all the interrupts... That's probably it, right? It's using scanning returning 0 interrupts as a way to notice that scanning is not working. But if we get one spurious interrupt, then it won't actually notice, and we'll just have a single interrupt available. We can put that in the kernel config, right? Let's try that. Oh, Tuco. Yeah, that's my chair. Hey, Tuco. Tuco, Tuco. No. Squeaky. There's a question about whether Tuco still likes to fetch bolts. Yeah, he doesn't like it quite as much as he did at the old place where it was all concrete and there was plenty of stuff for the bolts to bounce off of, but yeah, he still fetches them here sometimes. I think his favorite toys at the moment are the, well, it's not a toy, but he really likes looking out the window. And he likes running on his wheels still. Still, for like short sprints, really. He doesn't run like long distances, but he'll demand that I hang out with him because he likes doing it together, and then we'll run for a little while, and then he'll stop. Okay, I don't know why. I don't know why I'm always getting like. I feel like anytime I program on the internet, it's like chat is trying to autocomplete what I'm doing, and it's like that's not what I need, nor is it what this is for. Like maybe you're not actually trying to communicate with me, and I should just ignore it. But if you're trying to communicate with me, then it's not really necessary. To go. Okay. Hmm. Not actually skipping the scan there. Probably just specifying that wrong. Admin guide. I think I was doing that right. The wrong module name? Should be the same as the name of the source file. Right, just i82365.doScan equals 0. Here's a question about what I'm debugging. I am trying to get the PCMCIA card slots on this machine to work reliably under Linux. It's an old voting machine motherboard. I guess I could turn off the other microphone because we don't have any good bird noises. Now it's all just background noise. Is that just uncanny? So that's just the timing flavored problem again. I was running that without the extra debugging, and now it looks like we got that resource allocation failure. This was with all those sleeps, but I don't know that that was actually enough. I think we might have still been busy, like flushing serial messages. Yeah. This is looking like at least partly a user mode race condition. Like if I run that again just sometime after boot, now we've got the disk. And there's network. Could that have been two race conditions? Like one in the kernel with the IRQ scanning and then one in user space with the resource assignment? Okay. I actually caught up before. I don't know how far behind the logs view was from reality before we actually hit that weight. So now we're allocating IROs, IRQs, we've got a disk. So it looks like the storage card is fully functional, but the network card is not binding. Well, it seems like I should change the disk image that I'm building to stop reserving IRQ3 because that's not doing any good, and should add that command line to my grub permanently. This is interesting though because the parallel ATA PCMCIA device seems to be working fine and it's not sharing an IRQ here. So that kind of busts one of the previous theories I was interested in, that maybe IRQ sharing was a workaround that fixed some potential chipset level issue we're running into. So here, dev-SDB is working. I don't know what's going on with the network though. Which slot was that in? Socket 1. Alright, so they both have devices registered. Looks like we set aside IRQ7 for the other slot, which is also not being used for anything else. We got some IO mem in that area we set aside. And no IO ports registered so far. There should be plenty of room though. No difference remod probing it. Okay, ejecting and reinserting from software. The device went away and then comes back. Still don't see anything trying to bind. Is UDEV running? I'm not actually using UDEV at this stage in the boot, right? I was experimenting with that, but then I tried moving that later. I wonder if I actually do need UDev for this. I don't know why we'd be in a situation where it sometimes works and sometimes doesn't, unless it has to do with the order in which things bind in the kernel, but that isn't quite adding up right now. I don't quite understand the format of this still. Yeah, I don't really understand how this binding is supposed to work normally. My understanding was that you echo you write a name of a device to bind using a per bus identifier. So I thought in this case that would either be PCMCIA 1.0 or just 1.0 or maybe just 1. None of that seems to be working. So I need to do some research on that and or just install UDev in this. My previous strategy was to put off the UDev initialization until after we had a real root file system and not use it for this sort of initRD-like root file system that we're booting up off of first. Hmm. We got some kernel developer bad memories around unbinding drivers. Yeah. I still feel really jumpy whenever I mean I don't really use Mac OS for much anymore, but when I used to use Mac OS more, and in fact when I used to try to do development on it, I I would just be 100% certain I was going to crash the machine anytime I'd unplug something from a serial port. And then I don't know if this has gotten better, but it was a long time ago last time I messed with the Mac OS 10 kernel, but the serial subsystem, which was still very BSD flavored and not IO-Kit flavored, uh, was just really not designed to have anything unloaded cleanly. It didn't seem like it was possible to do it without race conditions. Where am I getting a link to the PCMCIA driver documentation? I don't need links to stuff, people. Hey, come in. Hey. Boy. Meow. suggestion to add some bug repellent to the computer. That seems dangerous. That might affect the bugs that I want. I think it's more useful to feed the good bugs and then put the bugs you don't want somewhere else. Oh, now we got some of that good purring. Oh, I just was searching around and I found the original patch that adds that bind file. And there's a warning in the patch log to remember not to add a trailing carriage return when you write to it. That might have been the problem. I should try echo-n. Oh, to go. Is that a good noise? Yeah. To go. Chico's so soft. Okay, I need a quick restroom break, and then maybe I'll try sharing this seat with Tuco and see how this new disk image works. I guess I need something under the camera now. You know. Okay. Okay, it's got that i82365 option we wanted. Let's use this one. Okay. So this time the interrupt for the storage device seems to be not actually working, so that's going to time out. But the driver did bind. I don't know if the network is working yet. This has got to time out first. Hmm. Interesting. I had already run that, but running it again seems to actually bind the network. Maybe I should put those sleeps back in. Alternatively, like, I wonder what the minimum thing that I could do to implement this properly without UDEV would be. Like, I should look into how initRDs usually work. Does initRD actually run UDEV, or does it do its own driver binding? Is the network interrupt working? Seems like it. Oh. Anyway, that was all I needed to do before rebooting that. Okay, maybe this, but with more debugging, and see if the IRQs start to make any sense. If we even get the same failure mode when the debugging is turned up. Hmm. Hey. Hey, 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 hey. 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 Hugo's a very talkative kitty. Such a kitty. Oh, what are my log files saying? Trying to match. Tuco's got some good purrs. Okay, what even works? Not much, huh? Oh, there's the storage card. And there's the network card. Ooh, do we have both working? Oh, and those I/O resources are somewhat different. I think 8.3. So what have we got? IRQs 3 and 4, not shared. I don't know if we're getting any IRQs on 3. That's the storage. Got some storage interrupts. Can we DHCP? Oh, yeah. Okay, so network is working, but we're dropping its IRQs. So, I think that's the same state we were in last time. That's stable at least. Maybe I can look at the logs. So IRQ3, this is basically the same situation I was finding myself in before, patching the kernel to try to avoid IRQ3. So the storage device is working because it's getting, well, maybe not because. The storage device is working and it's on IRQ4, possibly unrelatedly. The network device has been assigned IRQ3 and seems like it got one IRQ, if that's even related. Oh yeah, Tuco is sitting on top of the scratching pad. That one is fish-shaped, so I'm always asking him if he wants to scratch the fish. I mean, I guess the other problem here is that things don't always reliably just start up correctly. And so like on this boot, I rerun the socket setup scripts and then the network card driver binds, whereas before it wasn't binding. Ah, why are we getting these hit messages? I thought that was coming from the IRQ scanning, which, are we actually not disabling that? Well, gosh, I've got to wrap up this stream. This has been going for a while and I've got another thing to do. But, gosh, I don't feel like we necessarily made a bunch of progress today. I am still not sure what the IRQ assignment issue is. I want to look closer at the IRQ scanning process since I'm not sure I'm actually disabling it properly at this point. But I also need to just find an angle to look at these logs through that actually highlights the difference between these different modes it can get into. Like, I need to know what is actually causing it. Is this just things not always starting up in the reliable order and some of those orders actually having a viable path to start up through, and some of the orders don't. So that's like the kind of thing that if I was running a full-on UDev at this point, then it would be able to resolve. I don't know if that's it though. I mean, we could try installing UDev and letting devices bind that way, but I don't think that's the reason things are not binding. And then there's the IRQ problem, which I don't even know what's going on there. I didn't see any difference between the two cards in terms of how they're setting up the PCMCIA controller IRQs. There's still this nagging sensation in my head that there is some platform level IRQ configuration that might be different depending on how these are set up. I'm gonna have to look closer at the programmable interrupt controller documentation though, because I don't remember anything that would be like that. It also might be worth just getting the system into one of these states where IRQs are not being delivered for the network, and then just debugging like what is going on there. Like, can we verify through some other means that the routing is still set up correctly? Can we try to simulate an IRQ delivery? Yeah, I mean, I'm pretty sure at this point that this has nothing to do with the individual devices, because I've been seeing basically the same IRQ failure on both the network device and the storage device here. Where'd you go? Yeah, so here we're actually booting off the network block device. We can actually boot if we have both the PC cards working properly. All right, well, we will pick up this debugging situation tomorrow. Hope you all have a good night. I will see you then. And, yeah, pet a cat in your local area for me.